We knew that there's an energy problem in AI compute. We wanted to find a way to make AI compute much more energy efficient without over optimizing, because the biggest improvements in AI happened from when the architecture changed. And it took us years of research to get that right. The idea is multiplications are quadratically more expensive than additions. It's a little bit like the holy grail of can you eliminate multiplications from math. We found a way to basically eliminate that. A few other companies, big companies, have realized also by now that this is the way to go. We're the first company to implement logarithmic math. You're not doing multiplications anymore, which normally are very expensive. You're only doing, in a way, additions on the chip in the hardware. So that saves a lot of area. That's like a 300% improvement, basically.
Hey listeners, I'm really excited about today's episode of Under the Banyan Tree. We're sitting down with Banyan Portfolio Company co-founder and VP of AI, Gilles Bacchus. He's raised over $175 million and is focusing on building an AI inference chip that outperforms Nvidia. We talk about the AI infrastructure ecosystem, building a custom ASIC chip, society's impact from using AI, productivity gains when running a company now using AI, and a bunch of other stuff. So let's dive in. It's Tech Week. Welcome to Tribeca, but you want to give an introduction to yourself?
Yeah, hey guys, I'm Gilles, founder of Recogni, co-founder of Recogni, running AI and product there. Yeah, happy to be here.
Awesome. Well, let's jump in. I think something the audience will want to hear about is this growth of AI and Gen AI. You know, one of these stats that I found really fascinating was the time to 365 billion searches with OpenAI and GPT. OpenAI and GPT actually got there 5 times faster than Google did. You're on the ground floor building AI inference hardware. You know, how big is the AI inference market in general going to get? How far along are we in that journey? Maybe just tell us a bit about the size of the AI inference market. Just seeing GPT's growth alone kind of tells us, I think, some early indicators, but would love to hear it from you.
Yeah, absolutely. So there's so many different angles that you can take in answering that question. So ChatGPT and Google search, right? That's basically text to text. You give it a text input and you get a text response back most of the time. Sure, Google image search and then image creation in ChatGPT, that's also text to image, you could say. I think it's really going to explode once we get to additional modalities, especially video. I just want to give one example to just make it clear how much we're still in the infancy of AI adoption. So if you take video, let's just pick one application where video makes a lot of sense. What could that be? For example, education. Okay, so let's say instead of having a human teacher, you have an AI teacher, but you can actually have some kind of a video call with that AI teacher. Every pixel gets rendered by state-of-the-art video model, similar to Google VO3 or this other model that just got released as an open source model from China, Magi 1 from Sand AI, right? So let's say you run one of these models and every pixel of that video portal of that AI teacher gets rendered through an AI model. If you do the math behind, so, you know, we have 1.8 billion students in the world. Let's say all of them would use an AI teacher on average for just 2 hours a week. So not even their entire, you know, like how many hours of education does a student have per week on average? Surely much more than 2, but let's just keep it at 2. Currently, the global electricity power consumption would 30x, and it would be based on today's cost to generate that. It would be like $100 trillion market. So obviously not even possible today, but it will happen at some point. Why shouldn't it, right? And that's just education. That's just 2 hours per week, not even for every human on the planet, right? Now, if you increase that to, let's get back to searches actually. YouTube search, right? Today, when you search on YouTube, you will get back results of human-made videos, obviously, right? So if you type in cookie recipe, you will, like, for example, me as a German, right? What very often happens when you do that, you will get back some search results from cookie recipes where they use self-raising flour. You can't buy self-raising flour in Germany. We got to add the raising aspect ourselves into it. So what's going to happen in the future is you type in a prompt into YouTube and it generates a video right in that moment for you. only listing ingredients that you will find in your local supermarket, maybe cooked by your favorite actor, with the perfect music in the background, perfect visual ambience. It'll be just perfect immersion, basically, always, right? You can also apply that to Instagram in many different ways. You can apply that obviously to things like Netflix. And so we're still so in the infancy. So I think statements that we currently hear where Jensen or other people are saying, oh, it's going to 100x, it's going to 1 billion x, I think it's actually true. You can make cases for that. So it's hard to answer that question. You don't know where will it be.
Right.
I think over the next few years, it's just going to continue at a very aggressive growth that you could somewhat model. It's maybe going to be like 200% per year or something like that, right? So definitely very fast growing. But eventually, whatever that means, 10 years, 15 years, 20 years, it's going to be so different from what we know today.
Yeah, I really love this example of in the future, you'll be on Instagram or TikTok or YouTube, and when you're searching something, it's not actually a video that's already been made that it will be shown to you. It'll actually be an AI generated video, and so much of content will just be generated by AI, but you wouldn't necessarily know that it was generated by AI unless the person generating it or the service wanted you to know that. And just how much compute that's going to consume, I don't think can even be calculated right now by like most people out there, if anybody.
No, it's unimaginable. You can put it in numbers, but it's really unimaginable. Like today, the latest and greatest AI data center racks from, let's say, a company like Nvidia that you would purchase for, let's say, 5 million, right? Just the cost to set it up. And then, of course, you have running costs, but let's ignore that for a second. That thing alone, using state-of-the-art AI models, and I'm sure they're going to get a little bit more efficient, but then also grow again in capability. So that thing can generate a single or maybe 2, maximum 4 HD video streams in real-time speed. That's it, like 5 million for that, right? So we're still so at the beginning of all of this.
Yeah. I wanted to ask you this because there's this concept that is floating around in the AI investor community. Bannion's the AI native venture firm. We're at the forefront investing many steps ahead of what the masses would probably see as commonplace technology. And something that fascinates me is this concept of a $1 billion company managed by one person. Or another concept is humans managing agents. So maybe one human used to manage 8 to 10 people, or they are a manager of managers, a CEO, manages the whole company and has their VPs of each department. Do you think we'll see a $1 billion company founded and managed by one person? Or do you think what's more likely is what we're going to see is people actually managing agents? Like, how is this really going to work? Like, I'm curious what you think, because, there's a lot of different concepts out there, and I'd love to hear, from your perspective, how you see it.
Yeah, I think there's no doubt that AI is very quickly now becoming a tool that can massively multiply the human output. There's no doubt about it. We're already seeing it. There's tools that allow you to very easily build such multi-model agentic systems that can, do a lot of jobs for you. So yeah, I think there's absolutely no doubt that even a $1 billion valuation or revenue company could be led by a single person.
So crazy.
Of course, yeah, it is crazy. Of course, at that level, right, if you really had $1 billion in revenue, let's say your profit would be just 100 million, obviously you would probably then hire more people and not just choose to stay that one person, right?
Right.
It just wouldn't make a whole lot of sense. But no, I think it absolutely can happen. And I have in fact noticed that going to conferences, the last few conferences that I attended, let's say in the last 10 to 12 months, I've gotten to know way more of these solo entrepreneurs who, when you talk to them and you just know a little bit about their business, you're assuming, oh, you guys are like 20 people or so. And then later you find out, no, it's just that one person. Yeah. So it's already happening. Yeah, for sure.
Yeah. I mean, I can attest to that. At Banyan, we see in the orders of thousands of different companies per month, just depending on the month. And I've talked about this on LinkedIn a lot, and some founders get it. Some people are like, hell yeah, like I agree, they get it. Others, I think, are not as happy about it. But, sort of the narrative I've been trying to put out there in the market for founders is like, look, the bar has gone up because of AI. What used to be the standard that you needed to reach to raise a pre-seed round, that has gone up. Like there is companies 6 or 8 weeks or 4 months into releasing their product with full-fledged products with hundreds of thousands of users. You know, I'd say the minimum now just to raise a pre-seed round is at least $100,000 from top tier capital, unless you are a PhD with prior experience and prior relationships with those investors, those angels, or a prior exited founder. You know, you can get away with just raising on a concept or your background. But for everybody else that doesn't have that explicit, you know, very rare 1% background, like the bar has gone up. And you can see this in data from Carta around even the Series A bar has gone up, you know, around 5 to 6x more revenues needed, more maturity around the company structure. And I think that's primarily driven just by investors saying, well, there's so much deal flow out there, there's so many AI native startups, but why would we invest in the ones that don't have the traction, don't have the evidence? So I don't know if you have any thoughts on that, but for me as an investor, I've absolutely been seeing that and been operating that way as an investor myself.
Yeah, I can totally see that. I mean, we as an AI infrastructure hardware company, we live in a little bit different dynamic. It's a very complex system, needs years to get to revenue and to product and to market and to be launched from, let's say, day one until product launch or revenue. But yeah, otherwise for, let's say, software startups, I can totally see that, right? I mean, as I mentioned, right, AI is this new tool now that allows you to be extremely cost effective and also a little bit faster, right? Even for more or less established startups or companies, I have a friend who runs a company in Germany, and I hope I'm not misquoting, but I think he went from 75 people or so in his headquarters. He basically has a kind of business where he also has a lot of people just operating in, something like a store, let's say. But in his headquarters, I think he went from 75 to 25 people through the help of AI, and it runs better than ever before. Actually, his output is bigger. Like he reduced his software programming team, I think, from like 15 or 20 down to 5, and he says he can achieve more now with these 5 people, without all the other noise that's going on and all the, probably sync team meetings and all this, right? He can actually achieve more now, and so I totally see why that reality that you're experiencing is true. Yeah, makes perfect sense.
This sort of reminds me of a question, and I mean, on that thought, there's different data, and we'll pull it up for readers after this episode and link it, but there's the notion, I think what founders should think about internally when they're setting OKRs or goal setting or just however they're running their companies is revenue per employee. And I think the older your company gets, the more the bar goes up for revenue per employee. That's a great point. For infrastructure products, it's a completely different journey. Typically, it's hundreds of millions of dollars over 5 to 7 years to get an actual ASIC chip out the door. We'll talk about that. Yeah. But on this point, I want to double down on that. What do you think that's going to be commonplace where, and we've heard a lot of press about that, and there's different data and research on this, but do you think the white collar worker, which now even in software could just be the standard front end or back end engineer, that maybe not the 10x engineer, but the engineer that gets the job done, is their job, is it in question now? I mean, you just gave this insane example of a company going from 75 employees down to 25, 15 devs, I think you said, down to 5. Is that the new normal? Like how should companies be preparing for this, potential change? Like what are the best practices?
Yeah. So the way I like to, it's a very important question, right? And it's the question that many companies are asking themselves, and many CEOs around the world and so on. The way I like to think about this question is the following. What does it take to, let's say, replace, it's a very bad, devilish word, but let's say to replace a human worker.
Right.
As long as that, thanks to COVID, we all now are used to working from home, right? So most or everything, sometimes everything that we do can be done through a keyboard, mouse, webcam, microphone, PC screen, right? These are all the interfaces that we as a human need to interact with that world where we create value and we get paid for it, right? That's it. We don't need to, walk our physical bodies to anywhere anymore, right? We don't need to be anywhere physically. That's just it. So what would it take for an AI or a non-human system to replace that? Well, of course, you can think about an actual robot sitting in your chair, and and that's also going to happen at some point. But of course, you can also just do this digitally, because all that a keyboard does is it records digitally, eventually digitally, your keystrokes, right? So, and there are absolutely tools already that can more or less watch over your shoulder, learn what you do digitally, interfacing with your computer, and then just mimic that.
Right.
And if you and of course that now sounds a little bit complex, right? Because we're using so many different programs on a computer, right? So do you have access to all these APIs? Maybe not. Okay, then you maybe need to operate from the content of the screen, right? Which is very raw. It's like visual input. It's pixels. So first you need to read that. But even that is pretty possible now. So all the, let's say, AI model ingredients already exist today to replace someone, but there's still some complexity to it. And of course, there's also trust issues and compliance and so on. But generally speaking, it's absolutely possible if you think about it that way. Yeah, and so I think it will happen. And if you want to boil it down to something more simple, imagine you're having a video call, right? So going back to the video modality that I like to talk about, because it will represent a very large chunk of the compute that we need in the world, because it's so computationally intensive. If you have an AI twin of yourself who can talk exactly like you talk in a video call, right? Your AI twin, your video AI twin, that thing can basically do a video call on your behalf while you're in the kitchen cooking your lunch, or while you're having another call that is actually more important, right? How often do we all experience that we get a conflict, right? And then there's this one call that is super low priority, but ideally you would like to take it because maybe it'll grow into something bigger. Just have your AI twin handle that call. Later you'll get a report, or maybe you can just watch the whole recording and see what happened there. Probably you won't. After 3, 4, 5, 10 times, you will stop doing that. You will just trust the AI, and that can easily happen today, right? You can just have an LLM that learns from the transcripts of whatever you said in previous video calls. You can have something that visually learns how you move your face and stuff. This is already happening,
right?
So yeah.
Yeah, I mean, I've seen and read and met with many deepfake detection companies, and that's an emerging field of technology where a CFO can be spoofed on sending a wire to a potential client or a payment that needs to be made, and they get on a Zoom and they're confirming wire information, and they can't actually tell. And this is here and now. This isn't future facing. This is happening now. You can't actually tell that digital person is fake or not real. Yeah, so I mean, there's tons of fraud and abuse and issues that society is going to have to figure out. But it's also exciting because I think on this point of reorienting the workplace, I think people should get closer to working on what they truly want to, not what they have to, and automating a lot of the things that are just grunt work in any industry. I'm still of the thought that majors like art and science, political science, majors that require thinking and reasoning will be more important almost now, because AI is replacing so much of the software engineering. And I still see a world where trust and relationships, communication, decision making, synthesizing information, even if AI agents are doing that initial line of research, I think the future world still will demand humans making decisions and building trust. So I'm still of that thought, but it sounds like there isn't best practices yet on retooling the workforce or how to do this all. People are just figuring it out kind of as they go along, and your buddy had figured out his max productivity threshold with the current technologies, and he made the decisions that he made. Yeah. It sounds like.
I want to comment maybe quickly on the deepfake, or generally the fake problem that you that you mentioned. 2 years ago or so, I was asked, I think for the first time, how do you think this new age of AI will change us culturally? And the first thing that came to my mind, and I still would subscribe to that, is truth as we know it today will at some point maybe stop mattering and will also matter less in the future, because it'll be so hard to detect and to differentiate, truth from fakeness. But also at some point it'll be so complex, because it'll be like multiple layers and like one fake truth feeding into another thing that maybe is true, and then you have a truth based on some fake stuff. And at some point, I think culturally we're going to give up, and we will then concentrate this experience of truth and of authenticity. We will probably restrict that to the world that we as humans can also experience physically. So through feeling, hearing, touch, like human to human, right? I know right now that Sam is in this room. If all of this happened digitally, who knows, right? And who cares also at some point? That's my point. So so as long as it stays within a purely information kind of world, and it doesn't interact with the physical world, I think the value of truth will become less after some time. Example, let's say you wanted to entertain your little party that you have at home through a little joke or something, or a little cool story, and you go on ChatGPT and you ask, hey, can you just give me some entertaining story? You know, like the conversations are dying down right now. I need to, like, you know, spice things up again. And it's going to give you a story that might be completely made up, but it's actually entertaining. And then at this point, who cares? Like, who cares if it was an entertaining story and it sounds plausible? Who cares if it actually was true or not? And that's a new cultural reality that we're going to have to get used to, because it's going to be too hard to fight that.
Right. Yeah, it's really fascinating. I mean, I think technology and innovation has unintended consequences. When we're building, and you're a technologist, I'm a venture capitalist, when we're building or investing, it's very purposeful. Like, we're building this to achieve X. But I don't think what we're so good at is predicting the unintended consequences. Like, I don't think when Mark Zuckerberg founded Facebook and scaled up Facebook to what it is today, he really thought about political misinformation, or, you know, people being harmed or misled, or, you know, I think there'll be unintended consequences with AI, and it's really fascinating. Your view on it is people just at some point are going to stop caring and care a lot more about the in-person interactions, because
Maybe, yeah.
Things are already so hard to know what's real. Like, you have Trump with Truth Social, literally the name, and you know, he got kicked off X, and then Jack Dorsey sells X to Elon, and now Elon's in Doge, and I think people are just drained on already in the current state. Now you add AI that can create media at such a rapid clip, faster than humans can, and in a lot of ways better media. Like, it's just, how will humans know what's real or fake? That's like such a, I think, philosophically very important question now in our society.
Absolutely. I mean, now on YouTube Shorts, you have these clips where some famous person like Elon Musk will talk about something he experienced with Mark Zuckerberg, and you can tell from the content, probably that's completely made up, because it would be pretty crazy for Elon Musk to talk about this that openly.
Right.
However, given the lip movements and the voice and everything else, visually, everything, every modality that you're experiencing through that video, it's completely realistic.
Yeah.
And so
it's crazy.
What do you do with that, right? At some point, that's my point. Like, we're going to give up because it's going to be too hard to differentiate and to even ask yourself that question and go through the pain of finding out, is that true or not? And
it reminds me. So the other night I was on a walk to dinner with a friend, and we had one ear pod in each, listening to music, and she says to me, she says, hey, at the end of the song, by the way, this song was AI generated. And it just blew my mind. It didn't go through my mind once that this was an AI. I was, singing along in a good mood, the waters to the left, the sun setting, and I'm listening to AI generated music, and I don't even know, and the other day my brother sent me an AI generated song, and that one I knew because he had sent it, but it still sounded pretty good. And I think it's just an example of like what you're saying, and it's already happening. Like, it's already here, folks. It's not some future facing problem.
And if your friend would have never told you that this is an AI
I wouldn't have known.
You would never start caring about
and I wouldn't have cared. I was just happy to hear a great song.
Exactly. The good experience would have been that would have stuck forever, and that's it.
Right. So shifting gears, Epoch Research produces a lot of great data on the AI infrastructure market and trends, etc. One of the data points I read about was from 2019 to 2025, the annual growth of chips per cluster has been 1.6x. So more chips per cluster like 1.6x every year. It's increasing from 2019 to 2025.
Yeah.
So where are we headed next? Tell us more about algorithmic math and Recogni. Maybe the readers, listeners can have more context on your guys' technology, but also just, will this pace of innovation in the AI infrastructure space continue, or are we going to slow down here? Like, what's really going on? What are you anticipating? And of course, give us the context on what you're building.
Yeah. So the reasons behind the number of chips in one cluster, whatever cluster here means, I guess cluster probably means that from a network topology point of view, you have more and more chips in one network cluster, so every chip can talk very quickly to every other chip. The reasons for that are multifold. So I'm going to try to also ground that in the Recogni story, basically.
Sure.
So today, you can't manufacture chips that are arbitrarily large, right? There's a physical limitation today. It's around 830, 840 square millimeters. That's the maximum die size that you can produce, right? That's true for AMD, that's true for Intel, Nvidia, for us, everybody, right? That's the maximum size. And most of the time you don't even want to go there because of yield issues, right? Because there's random errors in chip production, and the bigger the chip is, the higher the likelihood is that your one chip is affected by an error, and then the yield gets lower, the production cost effectively becomes higher, and so on. So you have that limitation, right? So based on today's state-of-the-art nodes, like let's say 3 nanometer manufacturing at TSMC or 4 nanometers at Samsung or whatever, you can really put more than 2, 3, maybe maximum 4 petaflops of compute within that chip area. That's just what it is, okay? Because you need a certain amount of transistors. You probably want to do math in at least 8 to 16-bit. That's just what it is, right? That's, again, for us, that's the case for Nvidia, for AMD, Intel, everybody. Sometimes when you take much more exotic approaches, which have other shortcomings, you can extend that maybe to 10 petaflops, but there's a limit, right? Now, if you only have a limited amount of petaflops, right, of basically operations or mathematical operations you can do per second, then what does that mean for these really huge new models? It would take longer and longer and longer to execute your ask to an LLM, to ChatGPT, for example. It would take longer and longer, the bigger and bigger the models become. So what you want to do is you want to hook many chips up into one network so that you can distribute the work among multiple chips. Most of the time today, the limit we see is 8. So you would have, because there's a lot of standardized concepts where you have 8 chips in one network. And so you distribute the work throughout 8 chips. And then you can do the model 8 times faster. In reality, it might be more like 7 times faster or so, because you have some other negative effects of scaling up. But yeah, you can do the model 8 times faster, and then you can basically have an 8 times bigger model that is much better at answering questions or at solving math tasks or so. But you can do it in a seventh of the time that it would normally require you. Another thing is, and we're a company focusing on inference, so on executing already trained models. When you're training models, however, you will have many, many more chips in one network, but the network doesn't have to be as fast for certain technical reasons. Yeah, and so there, yeah, you will have clusters of 100,000 GPUs or even more, also less sometimes, but yeah. So.
Yeah, it's really fascinating. So do you think that how far are we from hitting innovator's dilemma where infrastructure can't be improved upon, or it's marginally better? I mean, so far, year over year, with each standard release of Nvidia hardware, it's been pretty astronomically better. And I think with Recogni and other companies in our portfolio, Positron, Akash Systems, BBB, they're all taking extremely unique angles outside of the Nvidia purview to innovate and provide a better inference experience in terms of cost, user experience, etc. But I mean, how much more innovation is ahead of us versus, we're getting to a world where it's only marginally better?
Yeah, I think there's still a lot of things we can do. We as humanity to continue down this path of higher and higher density and more chips in one network and faster chips. I mean, first of all, the chip manufacturing companies around the world, and all of their suppliers, they're not doing all of this alone. Such as TSMC together with ASML and other companies, they are definitely further, marching down the path of Moore's law and, going to 2 nanometers and then 1 point something nanometers and so on. So this will still continue. It's always like a 20, 30, 40% improvement in area and power and speed. That's how you can think about it. So that's happening every, I don't know, maybe 2 years or so. Then there's other fundamental things. Like we, for example, as a company, what we've done is we've done some very deep innovation on the math side of things. So that's very agnostic to the manufacturing process. That's even agnostic to the kind of AI model you would execute. It's really about how do you do the math of, multiplying 2 numbers or adding 2 numbers. So there we've implemented, we're the first company to implement logarithmic math, which basically means you're not doing multiplications anymore, which normally are very expensive. You're only doing, in a way, additions on the chip in the hardware. So that saves a lot of area. That's like a 4x improvement easily. So that, is like a 300% improvement basically. And then there's other things one can do. Like, for example, you could make each chip a little bit less fast and dial back that, but then have many more chips in a fast network together. And there we currently see the formation of new open standards like UA Link, things called it, and Ultra Ethernet. And so some open, like multiple companies coming together, basically establishing open standards for networking. So there's so many reasons why we will definitely continue down the path of having faster and faster chips. And right now it might seem like, maybe it's plateauing a little bit because there's a little bit of convergence on how to build a chip for AI, but there's also a lot of new fundamental, or basically processes on the physical side, so analog computing or neuromorphic. There's photonic computing. Yep. There's going to be at some point quantum computing. So there's these things also happening, which can give you another big boost. Yeah.
Right. Yeah. At Banyan, we haven't made any investments yet in analog, photonic, or quantum, but we are in diligence and meeting and following along a few, and I think those are much further down the road fields, but there is companies building and showing some signs of promise. But just real quick, tell us more about logarithmic math. Sorry. I've read about it. Obviously, we're an investor in Recogni. That's why we're here today. But for the listeners, maybe talk about the math principle and how it influences chip performance on the inference side and any other disciplines that are influencing better chip performance, because there's other companies that are trying to be standalone AI inference chip providers. You have Etched, you have Positron, you have Grok. Grok's received pretty good notoriety and success at this point. You have Recogni. So tell us about the disciplines, because that's where I spend a lot of time as an investor, is reading about the disciplines, how is this company creating a wedge and something sustaining that will give them a competitive advantage to sell hundreds of millions or billions of dollars of revenue in inference chips. So maybe educate us on the different disciplines that you know of as a AI inference chip founder, and then talk about your discipline and your domain, because I think people will find that incredibly fascinating to learn about from you.
Yeah. So when we started the company, we knew that there's an energy problem in AI compute. At the time when we started the company, we were actually focused on edge AI. So it was even more than today about low power, like doing loads of operations per second within a power envelope of maybe just a mere 5 watts or so, or 10 watts, something like that. So it was and that was back then at 7 nanometers. So a much older node or process than what we have today, which is 3 nanometers, what we're doing right now. And we wanted to find a way how to make AI compute much more energy efficient without over optimizing for example, one type of AI model architecture, like Etched AI is doing, right? Etched AI is saying we're betting massively on the fact that AI model architectures transformers, which is the prevalent kind of architecture today, that this will stay the same way and we're going to build chips that are only optimized for that. We don't do that. We think that's a very dangerous bet, because the biggest improvements in AI have most of the time happened from when the architecture changed, right? The mathematical graph architecture changed. So betting on that not changing is a little bit like betting on the fact that we will not see another big jump in AI capability in the future. That's an odd bet to make, so I would not make that bet. I think edge AI is on a very risky path there, but let's see. And so most other companies, I think edge AI are the only ones doing that, will try to build a chip, and that's definitely a very hard, compromise to find as a chip design company. They'll try to design a chip that is very efficient, quite optimized on a lot of things, but at the same time still fairly agnostic to the workload that's happening. Because it's not all LLMs. Even today, it's not all about LLMs, right? Like companies like Meta, they still have a lot of old, let's say, convolutional neural networks, which is somebody uploads an image, and then within microseconds or so, you need to understand, is there brutality or violence in that image? Is there nudity in that image, right? So it's going to get checked very quickly. And that's not a transformer. That doesn't have to be a transformer network. So when we started the company, we wanted to do something that is fundamentally different. And it took us years of research to get that right, because it was very complex. But that is otherwise agnostic. So you can put it in any kind of AI chip. You could apply it to training, to inference. You can apply it to edge AI. You can apply it to the data center. This also, by the way, allowed us that when the ChatGPT moment happened to pivot very easily to the data center, because the technology didn't care about whether it was computing an AI model for some data center use case or for an edge AI use case.
Right.
And then, if you want to dig one double click basically deeper on logarithmic math, the idea is multiplications are quadratically more expensive than additions. And so, it's a little bit like the holy grail of, can you eliminate multiplications from math? Because AI models, maybe this is something that many people don't realize, they're basically one giant mathematical formula. So, formulas that you learned about in school from physics and math, imagine that, but instead of having maybe 3 variables like, A, B, and C, you have 70 billion variables. That's literally AI today. And 50% of the time you're going to do multiplications, and the other 50% of the time you're going to do additions. And that also does include divisions and subtractions. And so multiplications are much, much more expensive than additions. Just a little bit how you learn about it in school, right? A multiplication, when you do it on paper and you learn about it in school, takes many more steps than an addition. So we found a way to basically eliminate that through applying the good old rule of the logarithm of a times b equals the logarithm of a plus the logarithm of b. So multiplying two numbers and then saving that result in its logarithmic representation, if that's what you want to do, and you have both of the numbers a and b already in their logarithmic representation, so everything is in logarithmic representation, then you can actually just add these two numbers, and effectively you have successfully completed a multiplication. Then the big question is, how do you then do the addition? Because now that we've solved the multiplication in the logarithmic domain, doing an addition in the logarithmic domain is very complex, and you would have lost everything that you gained in the first place. So we had to find very elegant mathematical solutions to that. That's basically log math. A few other companies, big companies, have realized also by now that this is the way to go. And we call it Pareto because it's so-called in the technical sense Pareto optimal in accuracy versus efficiency, which is always what you want from a number system in AI, or generally from a number system. So,
sure. Yeah. And I love that you mentioned the parameters in a model, and I don't have that graph pulled up or that data that I brought into this podcast today, but just the amount of parameter growth in large language models has been astronomical. I mean, I think we're close to, or we're soon approaching 1 billion parameters in a model, or trillion. Yeah, something like of that off the top of my head. Like that. Just completely mind blowing. So on this topic, like maybe tell us, because I think this is the AI native podcast, and we are heavily investing in AI infrastructure. Something I love these two words, the FPGA versus ASIC chip design. maybe teach our listeners some of the fundamentals. What do they need to know about FPGA? Why should that matter to them, and ASIC? And then I have some other better questions, I'd say, but this is like an entryway to that.
Yeah, cool. Yeah. So it's a good question also for me, not that we're doing anything with FPGAs at Recogni. However, for the first, for many years before Recogni, I actually worked with FPGAs. So you can imagine ASICs basically are completely custom chip designs. Okay, that's what all these big chip companies do, and we also do. Like Nvidia, Intel, AMD, they're doing ASIC design, right? So it's really like you start fresh from scratch and you just design a chip that is, just completely custom to what you want to do. And then on the other end of the spectrum, from a user point of view, there's a chip like, let's say you ran a program. So, the ASIC basically means you build a chip that is exactly how you want it for the workloads you want. And then on the other side end of the spectrum, you might have something like an Intel CPU, which of course is also an ASIC in a sense, but as an end user, you use that as a very kind of workload agnostic, generic processor, right? So it's a CPU, it's a central processing unit. So it can do anything. It can execute every algorithm in the world, but it's going to be very slow at it, right? And Nvidia became this AI company because it happened that in AI, you do a lot of matrix multiplications and things like of that nature. And GPUs happened to be very fast at that, and then they had the whole CUDA thing that they invested into quite early, and that made them the AI compute company a little bit by coincidence, one might say. And then in the middle between, let's say, a very generic but slow Intel CPU and an ASIC that was exactly designed for your workload, somewhere in the middle you have FPGAs. So FPGAs are also chips designed by companies like Intel or so, or AMD. Basically, you have a lot of tiny electronic switches, like literally switches on this thing. And the code that you write, it's not like exactly like a C++ program or so that gets executed, but you basically describe how all these little switches should be put into place so that once you then switch the chip on and all of these little switches go into place, this chip becomes a little bit like an ASIC just for that moment until you reconfigure it. But it's going to be, of course, a little bit less dense in what it can do per chip area or, per chip, let's say, than an ASIC. But it's going to be much faster at your application than an Intel CPU. So it's something in between, usually very expensive kind of things. But there are companies that have found ways to use FPGAs to then run something like a Llama 70B or so exactly, like to basically turn all these little switches such that it exactly executes a Llama 70B. And they've actually managed to beat something like an Nvidia H100, which is a little bit of an older chip by now, to beat them like by, 40% or so.
That's
so
right.
Pretty cool, because obviously an FPGA doesn't care at all about a change in architecture, right? Whatever comes up as an AI algorithm architecture or some new non-linear function, it can do it, right? It's going to reconfigure the switches and that's it. Yeah.
Awesome. Yeah. Can't say any specifics, but yeah, there is investments in the portfolio that have leveraged that approach with skipping ASIC chip design, going straight to FPGA off the bat, picking specific use cases and actually beating Nvidia's latest generation. And they're producing revenue. But just like Recogni, they're on that journey to ASIC, full tape out, really customizing things end to end. But that's a 5 to 6, maybe 7-year journey, hundreds of millions of dollars probably of capital needed, and a lot of extremely good talent. And once you commit to a decision with ASIC chip design, that's it. It's set in stone, and it's not until that next design, that next tape out, can you change it. And so that's historically why, one of the reasons why Inference chips independently of Nvidia, besides maybe AMD and Intel, have really struggled. It's because they haven't had a software stack like CUDA that you mentioned, where you could go in and as an AI developer easily train a model or deploy a model. Like it's too rigid on that chip because it's a software and hardware marriage that happens there, and Nvidia's gotten that right. Or they couldn't have enough capital or time and expertise to tape out an ASIC chip that actually does something better than Nvidia. So this actually leads me, I'm really excited about this question. It's a nice segue. So I was reading this morning, in a B200 GPU, there's 208 billion transistors in a B200 GPU. And then on top of that, to build a B200, there's over 20 distinct suppliers. So these are OEM partners producing the silicon, the memory, the networking, the cooling infrastructure, all the mechanical components. And really my question to you is, because you're living this, you are like doing this day in and out, is Nvidia just really good at making GPUs that the world loves and uses, or is it a more accurate statement to say they actually control this entire ecosystem of those 20 different distinct manufacturing processes that go into making a GPU? And keep in mind, they're at about 80% market share for GPU compute, which, keep in mind, arguably is probably one of the biggest markets in the world right now, right? And so this to me feels like a monopoly, and you're slaying a dragon, this little company out of Germany in San Jose trying to create an ASIC chip that tapes out and beats them and goes to market, and we have other portfolio companies doing the same. I mean, to me it's absolutely mind-blowing, but would love to hear it from you. Is like, are they just really good at making chips year in and year out on this ASIC chip process that you defined, or are they actually, is there something bigger here around the ecosystem that they're pulling the strings of and just had the first at bat 30 years ago, and they've just hung in there long enough to kind of control the way this goes from here? I mean, what's your view on this fundamentally?
Yeah. Definitely, Nvidia is an extremely well-run, well-operated company, and I'm certainly not the first one to realize that.
Yeah.
I think the stock market has realized that as well.
Right.
And every gamer for many years, and every AI person or using AI compute. But one thing that, for example, is also true when we talk to very large companies that are in dire need of better AI compute, there's certainly a lot of people complaining about the software tool chain that you get from Nvidia right off the bat, right? So they do have to do a lot of optimizations manually almost themselves.
That's right.
Because the Nvidia software is actually not that perfect as everybody always thinks, because they have CUDA and all. They definitely also have shortcomings, and they're starting to become a little bit of they're trying to do everything now, right? I mean, when you look at the last couple of keynotes, they're covering now the entire vertical for certain fields like, I don't know, scientific computing and even more niche sub areas of that.
Right.
At some point, it's going to be a very almost bloated kind of thing, right, as a company. They're certainly not anymore just focusing on really good GPUs and that's it, right? Well, with, let's say, the nice programmable CUDA world around it. There's even very good reasons why at some point they will become less programmable again and starting to close and make it less programmable, less accessible to the outside world in a kind of bare metal access kind of way, because they want to control more of the vertical, right? And then they will not sell you GPUs, which they're already not doing anymore. They will sell you entire data centers, maybe, or not even that, maybe just gonna have you pay per token or per hour of using their compute for a certain application. So I think they're definitely trying to get there. It's not going to take long until Nvidia has their own data centers, I think. Of course, they have to be careful, because otherwise the authorities are going to step in and say you're a monopoly, beyond what is
how they
healthy.
haven't already done
Yeah.
Blows
I mean, there's
my
definitely
mind.
been problems for them already.
Right.
But yeah, for sure, they have to be careful about that. Like that's kind of a known fact, let's say around Silicon Valley or so.
Right.
But yeah, I mean, Nvidia is really good at optimizing a lot of the kind of also production chain and procurement and kind of the whole supply chain that they have, right? They do a lot of stuff in-house, right? So they're very optimized. But one thing also, we as a company, right, because yes, we are up against a giant, dragon that we're trying to slay here and so on. But we're only focusing on inference. Now, yes, inference will become that huge market, but so far Nvidia is still not doing chips only focused on inference. And the reason is right now they're making a lot of money selling hardware that can do everything, and people are willing to pay for it because it's still by far the most usable hardware you can get.
That's right.
But they would self-cannibalize a little bit. They would cannibalize their own sales if now they suddenly did something that was only for inference. We as a company, we don't have any history in that market, right? So we can just do whatever we think is best.
Right.
And yes, we will absolutely do something that, uses log math and very nice chip-to-chip networking, and also integrate the latest and greatest agnostic technologies like 3 nanometer TSMC and HBM3 memory to build something that is optimized for inference. And there we can then easily have like a 3x, 4x, sometimes more, sometimes less improvement over the latest and greatest of Nvidia. So I don't know. I hope that answers some of the question.
I mean, it's such an important topic, and there's so many different ways that this conversation could go or where we could focus. But what I'm hearing you say is they're extremely proficient at building highly usable, reliant chips, the best in the world. It's arguably one of the bigger markets in the world, definitely the biggest market in technology. And it's powering our global economy. It's holding up the stock market. Nvidia has been doing so many good things for the world and bringing us like superhuman intelligence. But I think what I'm extracting out of what you said is, because they go so wide and they're doing so much with the same chip, they're not highly specialized for inference. Yeah. And inference, this is like one of the main issues right now. If you talk to a product manager at any company putting models in production with users, it's just like how slow the model is, how long it's taking. Inference is where the model meets the customer and either provides a world-class experience that makes that customer super happy, or the contrary, where the customer's like, wow, this is slow, this image looks like crap, or this whatever I asked the model to do, it didn't really do. So I think the specialization of what Recogni and other companies in the portfolio are bringing is highly necessary, because there's still such a gap with performance of these models and production, meeting the customer, and they're extremely expensive to maintain. Like when you roll these models out, I think here was like a stat I heard, like Google saying something like it's like 10x more expensive per search when you search with an LLM versus just historical search. And we're not even at the place where media is being generated. Like I love that at the start of the pod, like that's going to be 100x more expensive. So like just the cost of this stuff, how much infrastructure is going into it, is just sort of mind blowing. So it feels like the specialization, the Swiss Army knife, is why companies like Recogni deserve to exist, and knock on wood, should have like tremendous success.
I'm surprised actually it's only 10x. I didn't know that number.
I might be sandbagging.
But it could easily be 10,000x or so, because doing a Google search on their existing database of crawled websites, that's obviously not very figured out. But if you think about every time you search something on Google, it would ask a very powerful reasoning model, and you would want that reasoning model to give an answer within a second. So you would have to run it over maybe 64 or 100 chips in parallel so that it's fast enough. And maybe the utilization would also not be super high, because you can't put too many users on all of these chips in parallel. Otherwise, the response time for every user suffers from that. It could easily be 10,000x, right? But the value would be there, right? That's again my point from the beginning of the podcast. We're still so much at the beginning of all of this, because we have models today that would be nice if we could use them at all times, right? Just one completely different example that's also very interesting, I think, is if you're a trading company, right? High frequency trading operates in the domain of nanoseconds, microseconds, something like that, right? Now we're back at seconds, more or less, because what happens when a tweet or an X, what do you actually call these things? X tweet or X message? I don't know. Like when a tweet, let's say, gets sent by some person that can influence the stock market, let's say Elon Musk or Trump or so. It takes, I think, 5 seconds or so, I heard from a trading company, until the stock market reacts. What if you could? And then let's imagine something more complex, like a McKinsey report. Like the new McKinsey report comes out, 100 pages on global economy, right? And you want to analyze that. Now, normally it would take you maybe a week to really come up with a conclusion and how you want to trade as a trading company based on that. It would certainly not be part of the high frequency trading decision. But if you had an AI model that could completely autonomously parse that report within half a second with an extremely powerful reasoning model that can cross-correlate this with so many other reports that ever happened, and maybe perform a couple of searches online in parallel and come up with a trading decision within, a second or so. How powerful would that be?
Right.
But we're still so far away from that being feasible technologically. There's not an AI computer today that could literally do that.
Right.
It just doesn't exist yet. So companies like us are trying to build that.
Yeah. I love it. Yeah. Well, I know we're about to wrap up, but last kind of question that I love this stat. The Earth's circumference is 24,000, almost 25,000 miles. And if you're in a Nvidia DGX SuperPod supercomputer, which is a large degree of GPUs, it's estimated to be 40,000 to 60,000 miles of wiring. So it's as much wire, like there's so many wires in that supercomputer, it could go around the world 3 different times. So I mean, what blows your mind about the data centers? Because to me, at the scale we're building these things and how much energy they're consuming, they're one of the 7 wonders of the world. And you see Saudi Arabia pushing really hard, the Middle East. You're seeing Europe now getting really aggressive on their deployments of data centers. But like, what sort of, as a founder building an inference chip, fascinates you the most, or sort of just blows your mind when it comes to the data center? Because I mean, I think about it a lot. I just think it's such a fascinating thing.
What I like about the data center space is, and I'm also going to end it with an anecdote from one of the bigger data center companies that we talked to recently, is everything is pretty clear. What I mean by that is they know exactly what they need. They know exactly their KPIs, right? They know about power. They know about the CapEx cost, the OpEx cost, the total cost of ownership. They have analyzed to know
which power sources come in when, if weather is coming in, where to switch to what backup source of energy.
Like, for example,
it's all mechanically designed.
In a very state-of-the-art modern AI data center, the cost of running one rack, basically without any hardware in it, just the base cost of that one rack is around $100K,
right?
To run that per year. And so basically then you equip it with hardware that costs in the millions. And but everything is very well understood. And we talked to one very big data center company recently, and they said they're building new data centers where the entire data center is as if it was one piece of software. Right? Think about it, a real estate thing, right, with a lot of hardware behaving like software. So every little window, every duct, every door, every whatever is controlled by software, and it all is centralized in one point. And you, like, in the future you will not even need a single human anymore to operate these things, right? They're just these giant buildings and kind of AI factories, right, that are completely software controlled, software defined data centers. Maybe that's going to be a new term. So it's a nice world also to be in as a startup, I have to admit. The worlds that we were in before, such as automotive, definitely much more complex, much harder to wrap your head around. Like, what do they really need? A car, for example, right, is such an incredibly complex system, right, with so many dependencies. In the data center world, you also have that, but things are a little bit more clear. And as long as you can satisfy them and show them improvements on certain key KPIs, which are clearly understood, they're going to be listening to you, and that's nice. Yeah.
Well, awesome. I really enjoyed this today, and looking forward to our event tonight.
Yeah, absolutely. Thanks, Sam.
Thanks.